All right, recording. Okay, so let's talk. Data is info that comes from observations, counts, measurements, or responses. Observations is when you just watch and get information. Counts is just counting up something. This is like in sports. Measurements is actually measuring something, either volume, distance, something like that. Responses is asking somebody and getting information that way. Statistics is the science of collecting, organizing, analyzing, and interpreting data. So you have to be able to get information, you have to be able to organize it, analyze it. That's like getting information out of it, like the mean, median, mode, stuff like that, and then interpreting and deciding what to do with that data. A population is a collection of all possible data. And this is the data you have. This is a subset of the population. Yep.
So for the AP test,
Yep.
is there going to be vocab questions?
Yeah, there might be. It might say, they often do stuff like they'll have 4 examples or something and say which one is a parameter. And you'd have to like circle A, B, C, or D. Yep.
Was there like something, there was like a test last year that some kids took where like they took it together?
Like as a group?
Yeah.
No, this is not.
Someone was telling me.
In AP Stats last year, I think we did our final together. The kids took
Oh,
the
like
final
the
together.
exam. Oh,
Final
I
exam
see.
together.
I see.
Yeah, I'd do that for you guys too, if you wanted to. But no, this is definitely an individual test. You all take it in the same room with Miss Anderson. All right, example 1. The U.S. Department of Energy conducts weekly surveys of approximately 800 gasoline stations to determine the average price per gallon of regular gasoline. On December 10th, 2012, the average price was $3.35 per gallon. Identify the population and the sample. Okay, population and the sample. This is always a confusing question because one of these is in the problem and one of these is not. Anybody want to tell me what the sample is? Triton.
Oh, I was going to say the population.
What's the population?
The gas stations?
No. We're talking about the data. What data are we talking about, Triton? What do we care about the gas stations?
The price of, oh, so the population would be per gallon.
So it's the price of what? Of gas at which gas stations?
800 gas stations.
That's the sample. So the sample is the price of gas at the, what was it, 800? Yeah?
Is it all gas stations?
Yes, this top one is all gas stations. The point of looking at a sample is that we can't look at all gas stations because there's just too many of them. So instead, we look at a sample, which is 800 gas stations. But when you think about the population and sample, I don't want you to think about a whole bunch of gas stations out there. Imagine in your head, instead of thinking about like a whole bunch of gas stations in front of you, imagine a whole bunch of prices in front of you. That's the population. The population is the data that we want. We don't care what the gas station looks like. We don't care who is running the cash register. All we care about is the price of gas at that gas station. Okay. Parameter is a numerical description . of a population. And a statistic is a numerical description of a sample. Last year, a company with 65 employees spent a total of $5,150,694 on employees' salaries. Does that amount describe a population parameter or a sample statistic? Tegan,
Sample statistic.
is this all of the employees in the company? It says a company with 65 employees. Does it say that it's just a sample of 65 employees? Or 65 out of 1,000 employees? No, when it says the company has that they mean total. So this is all the employees of the company are 65. And since this is a population as in all of them, this is a parameter. A statistic would be if I said there are 1,000 employees in this company, I looked at 10 of their salaries, and here's the average. And then that average would be a statistic, not a parameter. Okay, descriptive statistics is just the facts. This includes stuff like your average, your median, any graphs you want to make. That's all descriptive. Just the facts. Inferential statistics is an educated guess about a population. Based on a sample. Yep.
So like to go back to the gas station example, it's kind of like they only surveyed 800 gas stations, not every single one in the United States.
Right.
So you can make an educated guess saying that the
That-
average.
Would be about that for the whole United States. Exactly. So like if we went back to example 3. So example 3, what Triton said, is that the average was 3.35 per gallon. The average being 3.35 per gallon, that's descriptive. I'm not making any judgments there, right? I'm just saying, look, we looked at 800 gas stations, here's the average. Facts. Everybody understand that? But then if I said, therefore, the average price of all gas stations in the United States is $3.35, that's where I'm taking an educated leap there. I'm making a guess about everything else. Okay? Nice job. Speaking of, let's look at this one, example 3. How do you feel about the speed we're going through this? Overwhelmed yet? Sweet. A survey of 750 parents found that 31% support their kids financially until they graduate college, and 6% provide financial support until they start college. So that means that this amount provide financial support until they start college, and 31% support until they graduate college. So that means we've got 37% of parents who are providing financial assistance after people graduate high school. Determine which part of the survey represents a descriptive branch of statistics. What conclusions might be drawn? Okay, so descriptive. What's descriptive about this? Just the facts. What do we got?
Out of this 750 parents,
Okay.
31% support their kids after college.
Right, and I'm not going to write all of it. I'm just going to write down that 6% that